There are a few programming languages that have really influenced the way we think about programming. C is the obvious one. You probably write in a language that looks a lot like C, behaves a lot like C, was maybe written in C. C set the template so definitively, you could be forgiven for thinking that that's what programming actually is. But there are others. There are a few other big players that have changed the way we think about programming. Lisp, for instance. You probably don't write Lisp, but if you think garbage collection is a normal feature for a language to have, if you think functional programming is a useful technique, then you can find your roots in Lisp. Another one is Prolog. You almost certainly don't write Prolog, but you can see its influence as an idea in SQL, which is a very everyday language. You can see its influence in any language with type inference. While we're on this list, we have to mention Grace Hopper. She was the first one to suggest that we could talk to computers at all, instead of just typing in machine codes. She changed the game of what we think programming is. There are some languages and some people who have absolutely set the mold for the future of computers. And there's one language like that actively intended to change the way we think about computing. And it has been influential, but not yet to the degree it hoped. Smalltalk. Smalltalk is the language that popularized objects, so it's hard to imagine Java without it. It popularized message passing, so it's hard to imagine actors or Erlang without it. But in a way, objects and messages were just the means to an end. Its real vision for computing was something far bigger. So what was it? What was Smalltalk's grand plan? What is it? What can we learn from it? What untapped design ideas does Smalltalk have for us? Joining me to discuss all this is Juan Vuletich. He's the creator of Cuis Smalltalk, and he is both an encyclopedia for Smalltalk's origin story and a torchbearer for its future. So when I wanted to know what this language is all about, Juan was the perfect person to bring in for a big chat about Smalltalk. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Juan Vuletich. Joining me today is Juan Vuletich. Juan, how are you doing?
Hey, I'm great, thank you. And you?
I'm good. And thank you for joining me, because we've got to open with a really big question and then work our way into some details. Because you're the author of Cuis Smalltalk, and we're going to get into the full depths of what that is.
Yeah.
But we have to start with, what is Smalltalk? Because it's a language, it's an operating system, it's a philosophical set of... What is it?
Well, yeah, Smalltalk is a lot of things. It is all of those and maybe others. The important thing is that Smalltalk is kind of an attitude. Okay. This starts with an old quest from the time when the idea of a personal computer was not yet a reality, and the question was how to give people effective access to the whole power of a full computer for themselves. Okay, not a shared computer, but a personal computer. If a user could have the full power of a computer, and that was meant to be a lot of computing power for one single user, what's the best the computer can do for them, right? This was in the early 70s. So everybody has way more computers than that for each of ourselves now. And the idea, the question was how to empower users. And the obvious answer is that computers are good for handling, managing, editing, modifying knowledge. Okay, so the idea is to give people tools to model knowledge, to learn, to help them learn better, to help them communicate knowledge more effectively. And from that abstract and big question, well, what to do after that? Okay, so that's how the Smalltalk philosophy and the Smalltalk project started. Okay, so
right.
designing a programming language and building a development environment was the chosen path to give people effective access to computing power. Okay, so the idea of Smalltalk is to build a system that helps people learn, describe knowledge, communicate knowledge, uh, essentially that. Yeah.
Yeah, because it's in those days, right, when I can see this. I can see that being the necessary problem of the time. Computers exist just as room-sized things in governments and labs and some companies.
Exactly.
And historically, you're just on the on the cusp of people getting like Spectrum and Tandy computers in their home.
Yes, that was later. The Smalltalk project started a bit before the first microprocessors, just a tad before.
Right. So
And
they are looking into the near future, thinking, what's the world going to be like when this happens?
no, they were actually
No.
looking into a mid-term, long-term future. They were thinking about a decade or two in the future.
Right.
So what they built was way more ambitious than what the first microprocessors could do. But they already knew about Moore's law. So they already knew that it was quite likely that computing power would become more widespread and cheaper. So even if the microprocessors that were just around the corner would not be good enough, it didn't really matter. Better ones would come afterwards, or whatever was needed. They were not focused on a specific technology.
Right.
Um,
Yeah.
Actually,
Okay.
the first computers on which Smalltalk was developed, the Xerox Alto, was a kind of mini computer of the day, sort of a box on a desktop, something like
Right.
that.
Yeah.
Yeah,
I've seen the photos, and they're small by the day's standards, but huge by our standards. Right.
yeah, and they were done with discrete logic, right? Uh,
Mm.
the way computers were done at that day. Only later, when AMD did a bit slice processor, they did a later version called the Dorado that was way faster, and that used to do a 16-bit processor, 16-bit chips, each one a 1-bit processor. So that that chip by AMD, I don't remember the name, was meant to be used that way. If you want an 8-bit processor, use 8 of them. If you want a 16-bit processor, use 16 of them. And
Oh,
that was way
really?
faster than the earlier technology. And that was around the time of the 8-bit microprocessors. But this
Right.
let you build something more expensive and way faster. Yes.
Yeah. Yeah. I can't quite imagine how that architecture would play out, but that's another rabbit hole for another day.
Yeah, and I'm not really an
Yeah.
expert in hardware. I just read a little bit about the kind of things they did before microprocessors were good enough to run a full Smalltalk system. That was around the late 80s.
Okay. But in that historical context, then, it makes sense that they are looking far enough ahead that they're not tied to specific technological choices of the day.
Exactly.
That explains why. That
Yeah,
explains why it starts to look like a philosophy of how computing should be done.
it was a research project and a research project into what computing could mean.
Mm.
Um, we already had theoretical computer science. We already had theory of computation and, of course, logic and theory of information and that part of the theoretical foundation of computer science. But it wasn't clear what were the psychological and sociological consequences of widespread use of computers. So, what computers would mean for people, and they
Yes.
wanted to explore that and to take an active part on that. One idea that Alan Kay, who led all this project, said several times is that he still believes that the computer will bring change in human civilization like that of the printing press. Okay,
Yeah.
the possibility of printing cheap books and everybody reading and having ideas stored in a place where they will not be lost in the wind, and you
Mm.
can revisit them years afterwards and keep refining them, and that being cheap enough for anybody to be able to do that. That brought the Renaissance. Okay, that brought modern civilization
Yeah.
in Europe, in the Western culture, and later in the whole world. So Alan says that computers should are destined to bring a change of that magnitude in our cognitive abilities and the way the and the advancement of civilization. And he says that hasn't happened yet. Okay, so and the aim of their project in the 70s was to help develop that. Okay, so Smalltalk was their first their first milestone in that way, in that path.
Yeah, it makes you think it's wrongly named because with an ambition that grand, starting with the word small seems almost too humble, right?
Yes, yes. The thing is that they also wanted this for everybody. And
Mm.
they didn't want this for an elite. They wanted this for everybody. And when Alan Kay knew about Seymour Papart's work on Logo and on education and the idea of Mathland. Well, let's not go too deep into that because we will never end. But the idea that the computer could be a medium, an environment for learning for children was originally from Seymour Papert. When Alan Kay knew about his work, um, he thought that the ideal user for his Dynabook project would be children. That
Yeah.
for several reasons. One is that children don't have many prejudices that adults have that make things harder. And another one is he wanted a cultural change for humanity. He wasn't focused on making money next year. So he thought it was more important to help children be better thinkers, to make a substantial change in the quality of discussions and discourse in general between people. Okay,
Yeah. Yeah.
a
I mean,
significant leap in civilization. So he decided to focus on children. So because of that, Smalltalk tried to be as simple as possible and as approachable as possible. And I guess that has a bit to do with the name Smalltalk.
okay. Yeah, that makes sense. I mean, we're certainly some of the way there, right? I mean, anyone who's seen children with an iPad knows that children are absorbing technological ideas before they can even speak these days.
Yes, yes. The last time I remember Alan saying the computer revolution hasn't happened yet. It was in a talk here that was named exactly like that. The computer revolution hasn't happened yet, and I believe it was in the early 90s. I'm not really sure. I'm pretty sure it
Okay.
was in the 90s. So it was before the explosion of the web and before the iPad and smartphones. Okay.
I wonder where he
Um,
thinks we are on that revolution now, because it
I,
definitely
I,
feels like it's begun.
well, things have changed a lot. Okay.
Yeah.
But he has always been critical of where the industry is moving, and in particular with the iPad. He said that the designers and developers of the iPad knew enough about what they were trying to do to try to keep doing the same. Okay, but that they deliberately decided to build a device that is much better for consumption of media than for creation or sharing. Okay, that
Yes.
that what they did is to be inspired by previous work, including his, and use the new technologies to do a kind of new TV, okay, where users consume media.
Yeah.
Uh,
An
it is true
iPad
that
gives you it gives you a curated experience in which you
most of the time,
participate.
and
Yeah.
only in the last perhaps 10 years, newer generations of the iPad with better pen and better software started to be really useful tools for graphic designers, illustrators, for example, for drawing. Today, an iPad for many people is as good or better than pencil and paper for creating art. And in these last years, they also got much better for musicians, and many musicians use iPads even on the stage.
Yeah. Yeah.
Originally, that was not the case; it was only for consuming media. But still, we are far from uh, a practical, real Dynabook. That
Yeah.
was what
Alan's
Alan
vision.
was after.
Because the one thing that seems to separate it is whilst you can project your vision into certain frames on an iPad, Smalltalk seems to me to be a fundamentally malleable thing in which you change what it is to suit you. We still haven't
Yeah,
reached that part.
yeah. The original dream of the Dynabook is really ambitious and includes the same level of freedom that you have with written media. Okay, you can grab any piece of paper and start writing with a very cheap piece of paper and a very cheap pencil or a ball pen, and you're creating, and that's it. So it's immediate.
Mm.
And you can grab any book, no matter how old, important, or revered it may be, and you can write on the margins of that book, and you can
Yeah.
scribe over it, and you can reversion it. Okay, that's immediate, and there are no artificial limitations on what you can do. Doing that, not only with all the media a computer can handle, Alan also says that a computer is a meta medium. That means that it's a platform for creating new kinds of media. Okay,
Mm.
and the computer is indeed that, but giving you full control over every aspect of that is very difficult. It's very complex. A computer can do a lot of things, and giving everybody the full power of controlling and tweaking every detail on everything a computer can do is a lot. Okay, and making it easy, immediate, and not requiring any special knowledge, we are very far from that. Okay, and devices like the iPad go from one direction, from the direction of being easy to use and slowly giving you more power. Smalltalk goes from the completely opposite direction, give you full power over very little, and later expanding the universe of things you can do by making it more comprehensive and sophisticated. Okay, in the ideal world, those two paths someday would meet in a place where you have all the nice things you can do on an iPad, but with the full control that a Smalltalk system gives you. We are pretty far
Right.
from there.
I can see that gap being bridged, but tell me more about the Smalltalk side of that world then. If someone lands on Smalltalk for the first time, what's this malleable full power experience they're going to have?
Well, um, for the people who go from the bottom up, let's say, working, wanting to have a system that is fully malleable, even if limited, Smalltalk is perhaps the best that has been built. I think it's the best that has been built. So what is Smalltalk? Smalltalk, this is for old timers, for people who really started with microcomputers in the 70s and 80s. Smalltalk
Okay.
is a computer where you can tweak anything like a Sinclair Spectrum or a Commodore 64 or a Radio Shack computer. It's
Yeah.
completely open. Everything is there for you to tweak. But instead of needing to learn assembly language, you have a language that is designed for humans and not for machines. And that's a big difference. So, what is Smalltalk? Smalltalk is a kind of virtual computer that is completely open, where you can go from high level descriptions of knowledge about something that you are interested in, um, down to bits in memory and pixels on a display, or keystrokes on a keyboard, or bytes on disk. And everything in between is described in the same high level language. And everything is alive for you to modify. So the big difference between Smalltalk and regular programming languages is that the whole system is live and ready to be inspected and studied all the time. And that encourages you to tweak it in ways that regular systems make it very hard. So it removes a
Yeah.
lot of barriers.
Do you know what it's reminding me of ever so slightly is if I'm browsing a web page in Chrome, I can open up the inspector and it will
Yes,
show me some of the HTML tags.
yes.
What I can't do is open up an inspector and drill down into the painting primitives or see which bytes are going across the network or being stored to disk.
Yeah, that's true. You cannot do that. You cannot do that. In addition, HTML was created as a human readable format, but later evolved into something that is usually too complex for people to read. Only very simple web pages can be written by hand, and most HTML is never read by humans. It's generated automatically by frameworks, and it's rendered by browsers. So, and why is that? Well, one of the reasons is that HTML is not good enough at handling complexity. So the way to handle complexity is with tons and tons of more HTML instead of good abstractions. Uh, so that programming, besides, of course, HTML is not a real programming language. That's why you have JavaScript. So
Yeah.
you need to count HTML, CSS, and JavaScript as the absolute minimum to build web pages, right?
Yeah, to do anything interactive. Yeah.
Yes, and Smalltalk was designed trying to make something that was powerful, using little code, little text to describe things. It was
Yeah,
done
but
with
how
a lot of care.
specifically does that work? What's the design thing that HTML has missed that Smalltalk can teach us?
I Well, HTML is not a real programming language, so I guess it makes more sense to compare it with a programming language such as, I don't know, Java, C Sharp, C++, or
Okay.
Python.
Yeah.
One of those. Compared to those, one of the things, compared with Java, for instance, Java came out after the object-oriented boom that was started by Smalltalk itself, and they tried to do something that was high performance, safer, more professional, or I don't know what. But they ended doing something that has a very complex type system and that requires type declarations all over the world, all over the place. So
Yeah.
uh, writing anything in Java takes a lot of text. Okay, even more than in C, for instance.
Yeah.
And
Yeah.
Smalltalk is strongly typed, but it's dynamically typed. Okay, so each runtime object knows perfectly about its type and the protocols it can handle. But when you are writing code, you don't need to say that. Okay, you just have an object, you give it a name, store it in a variable, for instance, and just sending messages to it. You just start talking to it, and it will react. Very little boilerplate, very little extra syntax, very little additional stuff. So everything is much smaller. And additionally, not having types means that you can do real polymorphism. It means that you can have a set of messages that many objects understand, and you don't need to type conversions of stuff. If the messages are meaningful, any object will handle them. When you send a message to an object, you are not really constrained by what the receiver is. You are only thinking on whether it can do what you want.
Right. If it
And
understands the message, it is one of those
exactly,
things. Yeah,
yes. And that's some of the reasons that make Smalltalk code to be more consistent in most imperative languages, whether object oriented or not. Yeah.
This is one of the fundamentals of Smalltalk that's kind of hard to see how it works in the large, because I don't think, as a Java programmer, I've seen some parts of this. I don't think I've had the full Smalltalk object-oriented experience. But it's to interact with another object is to just know where it is, to know its reference,
Yes,
and to
all you
send it
need
an
is a reference.
arbitrarily structured message.
Yes.
So
Yeah, that's it.
That's it. That's the whole thing, right? Okay.
That's the whole thing. If you want, you can ask. If you have a reference to an object, we say storing a variable, but it's not storing a variable. A variable is actually a reference. There are not by value passing in Smalltalk. Everything is by reference, and variables are references. So you have a variable that references some object. If you have no clue what to do with it, you can ask its class. Okay.
Right.
And then
which
you know
again
the
is
class.
just sending a message.
Yeah, it's a message class.
Yeah.
And to the message class, you can ask the messages it can handle, for instance. Okay, and now you are meta programming. You are programming the programming system itself. Okay, because and that's how the Smalltalk tools work. Actually, usually you don't do that. It's not considered good practice to all the time ask an object what it is or what it can do. Usually, you structure your designs in a way that generally you know when you have an argument that this argument will conform to your expectations, right? But if you're writing programming tools, they do that all the time, of course, because they are modifying classes and they are modifying methods and messages and stuff.
So the debugger will just use the same mechanism as any other program talking to an object.
Yes, the only thing that the debugger uses that most programs don't use is access to the call stack. Okay, when you have a message sent that is essentially the same as a function call, the only difference is that the binding to the code that runs is dynamic. It's not known at compile time who you're calling, right? That's the only difference between sending a message in Smalltalk and calling a function. When you send a message and the method that runs sends another message and they still haven't returned yet, you have a call stack, like in C essentially, or even in assembly language. And the call stack is accessible from Smalltalk itself. Okay, you don't need to query the call stack. It would not be considered nice practice. But if you're writing a debugger, it's exactly what you need. So the debugger asks for the call stack, and it can navigate the stack frames and go up and down and access all the variable scopes that are in there, right? And manipulate them. That's how the debugger works.
Is the call stack a different thing, or is that just yet another object you send messages to?
It's just another object. Okay, so in Smalltalk you have very few. almost all the words you use are defined in the code you can modify. There are very few reserved words, okay, almost none, but there are just a few. One is the word self. Self means to an object itself, okay. If
Yeah.
a method says self something, is talking to itself, okay. So that's a reserved keyword in Smalltalk. And there are a few others, not many. Just I believe there are five. And one of them is this context. And this context gives you a context object that is a stack frame. That is an instance of a class you can browse. It's part of the system, and that has its parent context forming a kind uh, of chain that you can navigate. And for instance, in Smalltalk, the exception system is implemented without support from the virtual machine. The same way the debugger is implemented in Smalltalk manipulating stack frames, the exception system does exactly the same. So when an exception is raised, the handling code navigates the stack in the same way as the debugger does it to search for which calling frame has specifies the handler for that exceptions to be able to jump there. So it's all done there in Smalltalk. You can modify the exception system if you want.
Okay, let me check I've understood that. So if I'm about to throw an exception, I send a message to my context
No,
and
if
ask if
you
it can handle the exception.
no, if what there is a hierarchy of exceptions. There is a class named error, for instance, and
Hmm.
you can simply say error raise. Okay, and that raises an exception. And error, there is other exceptions too. I'm simplifying, but error
Mm.
is a class, and a class is an object. So it has its own protocol and its own messages. And one of the messages it can handle is signal. So if you say error signal, then the class error will know how to work with the exception system. It's part of the exception system to do the stack navigation for you. You don't need to do it yourself. You just say
Okay.
you can say I want to set up an exception handler for one of these exceptions, for instance error, while I do this block of code. And then you
Right.
call your code that can do whatever. And if inside that code someone does exception raise, exception signal, the exception system will look for the place where you say, I want to set up this handler for this exception, and find the handler and run it. That's for
How
the
does it?
exception.
How does it look through that? Because it's not looking through the source code.
No, this doesn't use source code at all. It uses the stack chain, and well, the frames of the stack are instances of classes in the context hierarchy, and they have enough steps to do this without using source code. And they are
Okay.
rather sophisticated data structures. And they are sophisticated because during normal execution, you are running sheeted code that runs very fast. And these stack traces don't exist at objects because they would be too slow. So only when you need them, the virtual machine, the running environment creates them for you. So it gives you the experience of a very slow, full interpreted system where everything in the running machinery is object, but in truth, most of the time, all that is optimized.
Right.
But when it needs to show it to you, for instance, because you open a debugger, then it creates all the stuff for you. So the experience is great, but the performance is very good too.
Okay. Okay. So the world, from a programming point of view, is always presented as objects that you send messages to, but under the
Yes,
hood, that's being optimized away a lot of the time.
yes. Most of the
Yeah.
time
Okay.
it runs optimized. The running speed of modern Smalltalk virtual machines is in the same ballpark of JavaScript or Java. Not too
Okay.
far from them. They don't use the same uh, advanced optimizations. They don't usually do uh, adaptive recompilation of large blocks of code like JavaScript does. Uh, but simply because way more money has been invested in JavaScript than in Smalltalk.
Yeah.
But for instance, a modern Smalltalk virtual machine is way faster than Python and most other interpreted languages. The only ones
Okay.
that can run faster than Smalltalk are JavaScript, Java, and of course the C family that is fully
Right.
compiled.
Yeah. Yeah, that makes sense. Okay, so as you've introduced this, how far down does the message system go before we cross that threshold into the virtual machine, and what's the virtual machine actually responsible for?
Yes, that's a great question. The virtual machine sets the the boundary of the Smalltalk objects world. And one of the ideas of Smalltalk 80 was to handle a platform specific code inside the virtual machine. That means that your Smalltalk world of objects is independent of the platform. And you can take a running system from one architecture and suspend it and resume it in a completely different architecture because nothing there is platform specific.
Okay, so if it looks like I'm running my operating system on a Mac, I can save it at the exact point I was developing, move that
Yes,
over to Windows, and I would expect it to pick up exactly where the cursor was, for
you can move
instance.
it to a Raspberry, you can move it to a phone, you can move it to any kind of processor. It doesn't even need to use a similar processor. It's all abstract
Okay.
out. Yeah.
How does that work then? What's the virtual machine's job to get that to work?
Well, the Smalltalk compiler compiles code into a format that is called bytecodes. And then these bytecodes are a kind of a virtual machine language. Okay, it's
Hmm.
not too different from a machine language, but it's a machine language that knows things like object references and other low-level details, and it's not tied to a specific processor. And then it's part of the work of the virtual machine to sheet that into actual machine code for the machine that is running. So that sheeted code, you don't move from one machine to another, you just discard it. But you asked
Right.
about the boundary of the Smalltalk system, and
Hmm.
I just described one part of it, that is to isolate the things that are platform dependent. The other part are some services offered by the virtual machine that is part of this Smalltalk machine language, if you want, that is called bytecodes, and it's what we call primitives. For instance, if you want to add two um, integers that fit in a machine word, that's what we call small integer in Smalltalk. There is a primitive operation that does that. You don't need to do the addition of small integers yourself. That would be too slow. Okay, so
Right.
Smalltalk has a very rich numeric hierarchy that includes large integers and fractions, so you can easily do arithmetic with huge numbers without any limit on precision. Um, but the ones that fit into a machine register, into a machine word, are instances of specific class that is called small integer. And the virtual machine has services for doing small integer arithmetic, floating point arithmetic, and many other things. And there are a few other operations that are part of the virtual machines that are, for instance, um that are part of the assembly language. The assembly language is not fully object oriented. It has the idea of a program counter and jump operations. Okay, so
Okay.
in the this you will never do while coding Smalltalk. I'm describing the machine language to which it compiles.
Yeah.
In the bytecode level, in the uh, machine language, there are jump operations and compare operations, and your high level control flow operations eventually end up generating bytecode that compare things and jump, for instance. Okay, like any C compiler would do. In C, you write for, you write your initialization clause, your increment clause, and your limit check clause, and open your your curly braces and write your code in there, and the compiler knows that it needs to set a label in machine code to where it will jump for each loop. Okay, and that there is
Yeah.
one of those expressions that generates code that executes only once at the start, one that executes every time for the increment, and one that tells it increments before jumping back to see if it needs to jump back or continue. So a C compiler turns a loop instruction into machine code with jumps and comparisons and arithmetic.
Yeah.
The Smalltalk compiler does the same, but for the Smalltalk machine language. That is the bytecode.
Right. Well, let me ask it this way. So I know one of the things you did for Cuis was to replace the rendering engine.
Yeah.
If I've got the right terminology. How much of that work to replace the way Smalltalk is rendered in Cuis, how much of that involved changing the virtual machine, and how much of it involved changing the Smalltalk image that's running on it?
Well, the Smalltalk system, any Smalltalk system, lets you access the pixels on the screen. Okay, so if you wanted to, what I did, the same you would do if you wanted to experiment with a new renderer for graphics, for instance, is to write a Smalltalk model for it that just paint each bit, each pixel on the screen, and that is full Smalltalk and doesn't modify anything at all. And you can work quite a bit in that way until you understand what you're trying to solve. Let's not forget that Smalltalk is about learning and knowledge. So there's a lot of focus on understanding the problem you're trying to solve. It's not just about writing code, it's about understanding.
Right. Yeah.
And yeah, that is important. And then you come up with something that's starts to look like the solution you need. Okay, you cannot use that for real because it will be ridiculously slow. It will take minutes to draw a full screen. Okay, so
Yeah.
what do you do with them? Well, in this regard, not all Smalltalk systems are exactly the same, but the open source Smalltalk systems are. And they all derive, or most of them derive from the Squeak system that was built in the 90s by Alan Kay, Dan Ingalls, and their team. And they designed the VM in a way that you could add modules to it. Okay, you can expand the virtual machine. You don't need to modify the virtual machine is complex. You don't need to modify the execution environment. You don't need to modify the memory handling or the process scheduling or any of those complex part of the virtual machine. But you can add new modules. Okay, so this Smalltalk code for your software renderer can be semi-automatically translated into C that you can turn into a virtual machine module. So if you run Cuis right now, and for instance, you open a text window, type some text, and then, for instance, rotate the windows like this, you will be using the software renderer I wrote to draw true type fonts. And that is part of the virtual. It's a module that was added to the virtual machine. And that's why it's very fast. But if I need, and I will do that this year, I want to add dashed lines to the engine. I had them in a previous experiment, but the current version in use doesn't let you use dashed lines.
Okay.
So to do dashed lines, I already implemented this in the Smalltalk model. So if you want to use dashed lines right now, it will not use the virtual machine for those lines. Those lines will be drawn in Smalltalk. And that is used today by a project called Dr. Geo that is for teaching geometry to high school students, and it's used in several countries. They're using what I'm describing to you today. What I will do, they are doing today, they are using only for dash lines the Smalltalk version of the code. And that what I plan to do this year is to add that to the vector graphics plugin that is part of the virtual machine, and then that will also work at full speed. Okay, so the master code is still Smalltalk. The debugging, the developing, the experimentation is all done in Smalltalk. But when it is mature enough, it can be turned into a C and added to the virtual machine. But that C code, you never edit by hand. You only generate from Smalltalk. Okay, so it sort of gives you the best of both worlds. This was one of the very good ideas that Dan Ingalls and John Maloney implemented for the Squeak system, and we're still using it, and it gives you this level. So you can do real-time stuff, high-performance stuff in Smalltalk.
And just take it and go through some compilation process to turn it into what feels like a kernel-level module.
Exactly. It's exactly like that.
Okay.
Yeah. Yes.
That's cool.
So, yes, it's wonderful. Yeah.
That bridges us into something we have to talk about, which is what are you and what are schools and what are people actually using Smalltalk for today?
Well, there are many companies that are using Smalltalk. I don't have much of this in my head, so I will most likely forget. But one of the big, or perhaps the biggest, semiconductor chip design software is based on Smalltalk. So Smalltalk is used, yes, for driving the silicon wafer machinery. They use a Smalltalk system that has been evolving for a long time. You can Google a bit about this. I never worked with those people, and I don't really know much, but I know that Smalltalk is a very big thing for them. And I believe also most of the sea container traffic in the world is the logistics and the design of the allocation of resources and routing of containers is done by another big Smalltalk system that has been online for decades. I also believe that most of the financial models used by JP Morgan are also in Smalltalk. I heard they tried to migrate to other languages a few times and always failed, and they kept using Smalltalk. So those are some of the big business that use Smalltalk. Smalltalk is also used for education. There are several universities that use it for teaching about programming. And another important user of Smalltalk is a company where I work. It's called Labware, and we do laboratory software for the pharmaceutical industry and also for food industry and oil and gas and mining and other industries where they need to track processes and track samples and lots of units being produced, and being able to track each product that was manufactured and to comply with very demanding standards, like in the pharmaceutical industry or the food industry, or safety standards like in mining and oil and gas. Many industries use our software. It's one of the big players in this world, and it's done in Smalltalk too.
Yeah. Okay, but is most of your time in a Smalltalk instance spent working on Smalltalk itself, or working on software for other people? Is it your day-to-day OS? What's going on?
Today, because I have worked at many places and done a lot of different things at different times. One of the things I did that was super fun and demanding and interesting was a framework for satellite image processing that I did a few years ago. But today, working for Labware, I'm focused on Smalltalk technology. So I worked for several years on a proprietary VM for running a proprietary Smalltalk system for them. And lately, over the last year and a half, I moved to working full time on Cuis. So
Oh,
uh,
really?
yes, Labware is sponsoring the development of Cuis, and I'm no longer working on their proprietary software. Other people took over that job, and I'm focusing on developing Quiz and making it mature enough for big companies to use. That's the longer term objective. Most of the work I've been doing in the last year is about solving specific problems that big business need requirements from a Smalltalk system that hasn't been addressed before because it wasn't my focus. Before it was well, it was used for other businesses, and I use it at work for different projects over the years.
Yeah.
But only in the last year, the focus is on making it as solid, reliable, and as scalable for big teams and big systems as a commercial solution. Yeah, that's my focus.
That's that is interesting. And the first thing that jumps out to me at that is, how do you collaborate? Because it seems like Smalltalk is almost by design, like your personal book, your personal computer. How does it work between images?
Yes. Well, there has always been, at least since the first commercial Smalltalk appeared, someone assumes the um, the position, the role of a provider of a standard Smalltalk image, um, and most people work on top of that. Okay, that in if you used as commercial small talk in the old days, everybody used commercial small talk. Now most people use open source small talks. In the old days, it was a small talk vendor, okay, who you paid a license to use their small talk system, so they provided a small talk system. Right
Right.
now, there are several Smalltalk systems that are open source, completely free MIT license, but they are still maintained and developed by a small team of people. And other people in the user community, of course, they are free to do whatever they want to them and to modify them in any way. But if they build uh, improvements, if they build new tools or they fix bugs or they enhance the system in a significant way, what
Hmm.
community members usually do is to submit their changes for integration upstream. It works a bit like the Linux kernel. Okay, the Linux kernel is handled by a rather small number of people, but anybody in the world is free to fix a bug in the Linux kernel and say, "Hey, I fixed this." And if it's true and the work was good, it will be part of the next Smalltalk kernel, even if that developer is not part of the kernel team. Okay, it
Right.
works exactly the same.
What do I do? Do I send you a GitHub pull request with a bunch of small talk in, or do I send you my copy of the image, or what's going on there?
No, please don't send me a copy of the image because
Okay.
extracting stuff from the image is uh, not very comfortable. Okay, so yeah, for moving a code around, we use text files with Smalltalk code. If you go to the if you clone the GitHub quiz repository, it includes quite a bit of documentation on how we do that. And you can use pull requests, or you can just use email. We have a community email list, and the good part of it, it's the dynamic of each community. It could be different, but in our community, um, the way we do that is with via email. We use email threads for discussion of contributions and
Okay.
stuff and attachments. That's one of the possible ways. If someone, and it happened, does a bigger work, for instance, many people have built very significant pieces of software and they host their own GitHub repos. Uh, and they store their code packages there, the Smalltalk code packages in their own GitHub repos. And when some of them are um, convenient for many people to use, sometimes what we do is to bring those repositories into the Quiz Smalltalk GitHub organization. And the good part of that is that it makes easy for me and the other core maintainers to fix bugs or to keep evolving that code. If someone chooses to keep it in their own repos, to which I don't have access, I have all the code is public. Okay, I can clone any repo, and I can send pull requests to any repo, but I cannot commit to someone else's repo. If someone chooses to host their own packages in their own repos, they only them have commit rights, then they are also assuming responsibility for maintaining them.
Yeah, that's fair.
But when they give that code to become part of the Quiz Smalltalk organization, GitHub lets you have an organization that can have many repos, okay, handled by the same people. If we add these new repositories to the GitHub organization, it means that the community is taking responsibility for them now on. It's not third party. It's part of the of what the community will collaborate to maintain and keep going.
Okay.
So you can actually choose where you want to be there. Actually, there is several people who have their own projects in their own repositories. They don't need to be GitHub. Most of us use GitHub, but there are people hosting repositories in other technologies, and it's okay as they can handle source file. Yeah, it's your choice.
Okay. Is this something that's likely to move inside Smalltalk, or has it already? I mean, is there a Git client for Cuis Smalltalk? Will there ever be?
Well, there are several possible approaches to this. Quiz is part of a family of lineage of Smalltalk systems. Quiz was forked many, like 20 years ago from Squeak, and Squeak is still alive. It has a different set of walls from Quiz, but we run, for instance, on the same virtual machines, and we consider friends. Many people are parts of various Smalltalk communities and use several Smalltalk dialects. Okay, and another derivative of Squeak is called Faro. So the three main systems that run on this technology and that started with Squeak are Squeak, Quiz, and Faro, and they have a different approach to what you say. Squeak uses a proprietary version control system called Monticello. And that means that it doesn't use Git usually. It uses its own server software and its own file format and its own tools, and all the tools to work with that are part of the Squeak system. Okay. Faro moved to Git with a format for source code, and they built tools into Faro to work with with Git. Okay, using Git services right from the Smalltalk image. And in Quiz, I choose to do it differently. In Quiz, we use Git for versioning code and for storing code, but the Quiz base image, the official image we distribute, has nothing about. No, it doesn't have even networking loaded by default. If you want to use
Oh, really?
networking, you add networking. So all it knows by itself is about files. Okay, so we use an external Git client, usually the Git command line, and well-known file structure and file format for storing Smalltalk code. The big reason to do that is to keep the image as simple as possible. I mean, the Git client, the Git command line works well enough for our basic needs, and one of the idea of Cuis in particular is that the base image should only include the tools and the things that a Smalltalk developer needs to be effective. Anything else should be in packages you can load. It's still larger
Right. Yeah.
than base Python. Okay, in Python you import everything to work, and base Python includes very little things. Quiz already includes a lot more because it has this morphic uh, user interface framework with scalable graphics, and it has the debugger, the inspectors, and the browsers, and the compiler, and all those things are part of the Smalltalk system because they are needed by a Smalltalk programmer. But something like network access, uh, web servers, client, um, Git is something to be done in external packages to be loaded only if you need them, and if you don't need them, don't load them because you don't need that extra complexity. So
Yeah. Still.
Quiz tries to be minimalistic in that regard. So that's
Yeah,
why
I can
Quiz
totally
doesn't
appreciate that.
include a Git client by itself. Could it be done? It could be done. It could be ported. Perhaps the work done in Faro could be ported by someone if they want. Um, I don't think it will be part of the official distribution, but if there is people interested in doing that, are totally welcome, of course.
Might be a fun way to learn how to use Quiz and Smalltalk from the ground up, right?
Only if you are really interested into Quiz. Okay, my idea, yeah, you know that there are people who say the good part of Smalltalk is that you forget about the external world and implement everything in Smalltalk. Okay, and there are other
Right.
people who say the bad part of Smalltalk is that you forget about everything else and implement everything in Smalltalk. Okay, so
Right.
should you forget about the external world and implement everything in Smalltalk or not? Is it
Right.
better to call the external libraries like Python does, or is this better to forget about everything and do everything in Smalltalk? The truth is that you can do as you wish. Okay, Smalltalk offers enough freedom to follow any of these attitudes or any path in between. And this is my personal idea. Smalltalk is great for experimenting, learning, and documenting what you learn, your knowledge. Okay, so when you write Smalltalk code, you are writing knowledge. It's a lot like writing a technical paper. Okay,
Mm.
so if something is core to my business, is something I'm really interested in, is something I really want to learn about, and I really want to work on, I will do it in Smalltalk, no matter if some external library already does that. I don't care. Okay, but if something is not my core activity, it's not my core interest, and I need that, but I'm not really that interested in that, then I will call whatever is out there. Okay, so
Yeah.
for instance, I think that Linus has done a great work with Git, and I don't want to learn every detail about it in order to be able to
Right.
implement it myself. So I just called Git. Okay,
Yeah.
but I'm really into graphics, so I wrote my own vector graphics engine. I could have used OpenGL. I could have used Cairo, for instance.
Mm.
But I'm interested in learning, and I'm interested in the flexibility of being able to tweak it to work exactly the way I want. So that
Right.
I write in Smalltalk. It's not
Right.
everything.
So it's not so much that you're trying to make Smalltalk the operating system you live your life on top of, as much as it's like your research book.
Yeah, that exactly. There are people who go a bit in that direction and would like Smalltalk to be the only software that runs on the computer, and that is okay too.
Mm.
Um, and it was in the original Smalltalk system. It was the way because there was nothing else out there.
Yeah.
but today, for instance, we are using this web meeting software that can handle recording, camera, sound, everything. It's not written in Smalltalk, and I'm okay with that.
Okay, I did
If
wonder.
yeah, and I use a word processor, and I use a lot of things that are not written in Smalltalk. But for the things I am really interested in, I try to uh, to create them, to build them, because it's a way to learn. Right?
Yeah,
Building is
yeah.
a way to learn.
Oh, yeah, absolutely. Who was it? Oh God, it was Gerald Sussman, I think, who said that computers are the best system we have for clarifying our thoughts.
Well, I
Something
don't
along
know
those
who
lines.
said that, but is absolutely true. Yeah, yeah. I
Yeah.
have a good friend who is a mathematician. He has several published papers and work on mathematical journals. So he's a real mathematician, the
Mm.
kind of people who do real math and publish. And he used to say that when you are working in paper, everything works, and only when you try to make that work on the computer, you find all the details you didn't realize of. The computer is very demanding in that regard, even for a mathematician, for instance. Yeah.
Ah, yes. So this is what you're really trying to get to, the flexibility of a notebook, but with the rigor of execution.
Yes, yes.
Yeah.
And when with the dynamism that a paper cannot give you, okay, with simulations, with live graphs, interactive stuff, yeah, that kind of thing.
Yeah, yeah. It won't project your ideas out onto a interactive chart, for instance.
Yes, yes,
Yeah, yeah.
yes,
Yeah,
exactly.
okay. So
That
if someone, I mean, this is a double-sided question, but it's really the same question. If someone wanted to learn small talk, what would they need to know? And in what ways would approaching small talk change the way you think about solving problems?
what would they need to know? Well, um, when Cuis evolved and a community formed around it, we tried to give our own suggestion to that, our own solution to that question. Okay,
Mm,
so a good friend named Hilaire Fernandez, the author of this Dr. Geo system that I told you before for teaching algebra to middle school and high school students, wrote a book on quiz Smalltalk, and another good guy, Ken Dickey, and me help him, but he's the main author. So you have this. It's called the Quiz Book, and it's aimed at people who don't know about programming at all. Okay,
right.
so it starts from really from the start, uh, by and guides you to what we could call the quiz philosophy, or the small talk philosophy of learning on a computer. So that's our big answer to that. Please read the quiz
Okay.
book. It will be the answer. And read the quiz book with a computer at hand, where you can
Right.
play, experiment, do the exercises. Yeah.
And I get the sense that as a programmer, I'm going to look at this and say, the things I need to bear in mind is everything's an object. I can talk to everything and I can interact and inspect and change everything.
Yes. Yes. That's
Yeah.
absolutely
Okay.
true. Yeah.
Okay.
Yeah. Another thing that is a good example of that. Uh, Smalltalk 80 in the 70s only had 7-bit ASCII character sets. Okay, and
Mm.
later in the 90s, the character set used was the Latin character set of 8-bit, 1 byte, one of those character sets,
Yeah.
and it has been like this for quite long. And it was only not too far away, that I added Unicode support to Quiz. Okay, and
Okay.
to add Unicode support to Quiz, I didn't modify the virtual machine. I defined a new string class that has several instance variables and that it holds its internal state in a byte array in UTF-8. But it does. But you as a programmer don't need to work with UTF-8 or UTF-16 like in JavaScript or other programming languages where dealing with Unicode is super complicated. The Unicode string class is polymorphic with the old byte string class, and it does all the hard work for you. Okay, so I
Okay.
was able to turn an ASCII system into a Unicode system without breaking client code and without modifying the virtual machine, just by adding new class definitions to the Smalltalk system. So that's a good example of how you can modify anything, and that is not just because it's cool or interesting. It has very practical value. You can
Yeah,
really evolve
absolutely.
the system in any direction. So
That's.
that's cool.
I can't imagine any other system where you could actually overhaul a fundamental class like string.
Yeah, yeah.
Yeah, that'd be tricky. Okay. What do we want to leave people with? Where's the future of Smalltalk going in your hands?
Well, um, the objective of Quiz is actually modest. The quick Smalltalk system wants to be a Smalltalk 80 system. That means a classical Smalltalk based on class definitions and polymorphism, message passing, and not much else. It's still as simple as possible, but it keeps evolving as technology evolves in the sense of using the latest machines, 64-bit addressing space, high resolution displays with high quality graphics, so Unicode, of course. So the future for Quiz is still offer a system like that in the future, more polished, perhaps, as we keep enhancing it. But the interesting part to me is what can be done with such a system and what I expect people to do with such a system. And big news in that is Dr. Gio. Big news in that is the teachers like Hernan Wilkinson, Maximo Prieto, and others using Quiz Smalltalk to teach at universities. And in the perhaps not too distant future, I would like to focus again on things like music synthesis and sound digital
Oh,
sound processing. That are
yeah.
some of my long term interests, and also to give better tools to knowledge designers. The ultimate objective should be to build a real Dynabook. So
Yeah. Yeah. We
keep
still
walking in
don't
that
have
direction.
that, but
We still don't know how to do that. So actually, the real reason why I did vector graphics for Quiz is because I want to build writing media that for the reader is as good as PDF. Okay. So
mm,
doing, for instance, I don't know, Jupyter notebooks. Well, you will never write a scientific or technical paper in Jupyter notebooks. You need to write it in PostScript and render it to PDF to have something that is nice to read. And less quality than that is not acceptable. So
yeah.
how can I compete with that from Smalltalk? Well, I need a high quality graphic system, and I need a high quality text rendering system, and I need full Unicode. And one of the things that I
Okay.
need that I will be working in the not too distant future is a way to create mathematical expressions and rendering mathematical expressions like PostScript does, but from the Smalltalk system. And that
Right.
can be done.
Yeah.
It's not too difficult, and it's absolutely required for writing technical material, right?
Yeah.
So
Absolutely.
uh,
It's
I, I,
totally
I ex-
believable that the scientific papers of the future will be on something like an iPad. In many circles, they already are. But if that was alive, that would be exciting.
exactly. The best media for reading is still paper. PDF is paper, is electronic paper, but it's still paper-like, and
Yeah, yeah.
we finally need to move beyond that with something that is not worse than paper in any regard. Okay,
Yeah.
it must be as good as that and better when possible. Yeah.
Yeah, yeah. I can finally see the future you're heading for, and I
Yeah.
hope we get there. It will be a better one.
I think we'll get there. I'm not sure who will do it. I'm not sure if it will be done in Smalltalk, but if we succeed, it could be done in Cuis Smalltalk. Yeah,
I
that.
hope so. I hope so.
Okay, thank you for
I
that.
wish you the best of luck for that future, and maybe someone listening to this will be inspired by the ideas and become part of that future. I hope so.
Yes, of course. We Quiz is open source, MIT license. It's on GitHub. All the development and the discussions and the activity is open to anybody. We have monthly meetings. Anybody can attend. We have a mail list. Anybody can read and write there. Um, so anybody who thinks this is interesting, yeah, please join us.
Yeah,
We are
we'll
waiting for
put
you.
all those. We'll put links to those in the show notes, and when you finally got round to the music synthesis stuff, I'll invite you round for a jam session.
Oh well, I'm too shy to consider myself even an amateur musician. I studied music when I was a kid, um, but I don't play much lately.
Well,
But
it's
I
the
did
other great
write.
field of human experimentation, right?
Yes, yes. It would be great. It would be great. I have
Well,
written some music synth myself and samplers, and I plan to get back to that. Actually, my master thesis was on how to better represent sound in the time frequency plane. If you are into
okay,
that, it's an extremely interesting area. Yeah. Yeah, we
okay.
can do so much better than the short time Fourier transform. There are things to be done there. My thesis was a small step in that direction.
Oh, we might have to dive into that in another episode. I'll if I can dig up the paper, I'll link to it in the show notes too.
Okay, okay.
But for now, Juan, thank you very much for joining me.
Thank you, Chris. This has been great. A lot of fun.
Thank you, Juan. And quick story, in case you're wondering. Juan told me something that didn't quite make it into the recording. Why is Cuis called Cuis? One of the key implementations of Smalltalk was called Squeak, after the sound a mouse makes. And in one part of the world, there's this little roadside hamstery thing, and the noise that makes is Cuis. So that's the origin. If you're searching for it, it's spelt Cuis, or you could just head down to the show notes for links to the Cuis website and all the other references that came up in that discussion. While you're scrolling down to the show notes, if you liked this episode, please leave a like, rate it, review it, share it with a friend, and make sure you're subscribed because we'll be back next week with another interesting voice from the world of technology. Until then, I've been your host, Chris Jenkins. This has been Developer Voices with Juan Vuletich. Thanks for listening.